Okay, everybody, just to get started, what I'm going to do, if everybody just looks up for a second, and give me a hand here, will you? What I'm going to do is I'm just going to write down here a list of all the things, because last week I just realised we did quite a lot of stuff in Monday's class last week. So I'm going to write up a list of things that were kind of the learning outcomes from last week's class, and we're going to go through all of those again this morning, and then I'm going to write up the list of hopefully stuff that we'll get done this week, okay? So if you guys remember from last week, what did we start out with? The whole idea, I'm going to write these, maybe categorize these into stuff which is OO specific and then stuff which is kind of processing that we learned, right? So, encapsulation, C-A-P-S-U-L-A-T-I-O-N. So that's the idea that we can make classes to encapsulate things that we see on the screen, or in a software system, we can make a class. So we learned about fields, we learned about methods, we learned about constructors. Okay, so the other things that we learned about constructors, and in fact constructors kind of merits its own bullet point here. You guys might want to just take a couple of notes as well, okay? So from the perspective of constructors, we learned about what's a default constructor, and we learned about parameterized constructor. We learned about a concept called constructor chaining, which is calling one constructor from another. And we learned about when you use constructor threat chaining, what's the keyword that you use to implement constructor chaining? This. So we learned about the use of the this keyword in Java to implement constructor chaining. So yeah, so other Java things that we learned last week. You guys remember we learned a concept called references, or object references to give it its full title. So if you remember, we did the example last week where we made an instance of a class and we assigned it to another class, and we realized that all we were doing was copying the references. Do you remember that? Do you remember that example that we did last week where we made two instances of a class and we changed one instance of a class, changed one of the fields, and that actually changed both of them? Do you remember that from last week? So I'll do it. Okay, if you don't remember, don't worry about it, because I will do another example of this concept today. It's called object references, right? We'll do object references, and I'll show you a real application of where you need to understand the object references in order to implement something in a computer program. So what we'll do today is we'll implement some features on this game that we're making for these last few weeks of the course, and you'll see how you need to know how object references work in order to solve this bit of the program. So anything else that we did last week? Encapsulation, fields, methods, constructors, default, parameterized, constructor chaining, used to this point, or object references. From an OO perspective, I think that's kind of all the stuff we did. Then we added some kind of stuff which is, I guess, maybe some math stuff, which is all about the concept of a vector. We learned that you can add vectors. We learned that you can multiply vectors by a scalar, and that has the effect of changing the size of the vector without changing the direction of the vector. In other words, the way the line that goes from the origin to the vector, that's called the direction of the vector. And when you multiply a vector by a scalar, it changes the size of it without changing the direction. So we learned that last week. We learned that clock processing is a class called a p-vector. So the p-vector is the way of encapsulating a vector in an object. The processing gives us this p-vector class. We learned that p-vectors have got an add and a mult method. And we also learned that we can use sine and cosine to calculate a vector from an angle. So you can take an angle in radians, use the sine to calculate the x, use minus the cosine to calculate the y, and that will give you a direction vector from an angle. And that's pretty much it, I think, in terms of vectors. Is there anything else that we learned last week from processing? Yes, new processing stuff that we learned last week. So we learned a few new methods last week. In fact, I think we only learned 3 new methods last week, but they're kind of maybe 4 methods in total, right? So the new methods that we learned last week, we learned how to move an entire sketch or translate an entire sketch using the translate method in processing. And what that does is it changes the origin for anything that you subsequently draw. The origin is changed to whatever you set the parameters to the translate method. So if you go translate 50-50, then that moves the origin for everything you draw subsequently so that 0, 0 is at the point 50-50. And we can use this in order to implement things like autonomous classes, like components, or if you like, things in our scene that are autonomous. In other words, they manage their own position, they manage their own orientation. So it kind of builds on this idea of encapsulation. Translate, the other one that we learned was rotate. And rotate takes an angle in radians and will rotate anything that you draw subsequently by that angle. And in order to make this kind of autonomous, so the translate and rotate don't affect other things in our scene, we learned two new methods called push matrix and pop matrix. So the order in which we typically call these, in something like a draw method or a render method, you're going to call push matrix, then you're going to call translate, then you call rotate, do your drawing, and then finally call pop matrix to restore everything back again. And if you remember how we're going to draw things from now on, you know, in this new world of encapsulation and classes and making things encapsulated, we'll draw everything as if we were centered around 0, 0. And then we'll use translate and rotate to move everything and rotate everything so that it works and draws correctly. So that's a summary of everything that we did last week, okay? What I would like to add to it for this week, the next kind of thing that I'd like to do is it's a few simple things we'll do first of all, right? And some of this is related to Java and developing your OO skills, and some of it is just kind of stuff that, you know, is useful to know in processing because it will make our sketches more interesting. First of all, I'm going to just do a little bit on keyboard handling. We'll do a little bit on keyboard handling. Keyboard handling is just so that we can get multiple keystrokes at the same time. The reason for that is because today what I would like us to do is be able to make our little chips be able to fire bullets. Okay? So we're going to learn a little bit of maybe sort of game programming for this, but the most important concepts that we're going to be able to use today, first of all, this is going to be impossible to do unless we understand how object references work from last week, and of course all the vector stuff as well. But also, what we're going to do today, or what we're going to learn, is this concept of inheritance. Inheritance in programming. And that's the main kind of learning outcome from today's class. Is that okay with everybody? So that's the plan for today. Let's jump back to this list of stuff that we did last week and just see how this is implemented in the sketch that we made in Monday's class, right? So first of all, encapsulation, if you guys remember, we made this class called a ship class. If you weren't here last week, I think there's a video up from last week. So we made this class called a ship class, right? And we like to make classes to encapsulate things like software objects in our system that we're building. So we put fields, we made a constructor. What's the significance of the constructor method? How do I know that that's a constructor? There's two things. Two things. Number one, no return value. So constructors don't have a return type. You don't put void or ship or anything before it. Second reason, the second way that I know that it's a constructor, because it's a capital letter, of course, yeah, and also because it's the same name as the class. That's how you know that that's a constructor method. So what do we usually use constructors for? Yeah, so give me a bit more, what would we use it for? Yeah. Default values. Okay, so a constructor is usually used for stuff like default values. And so that's our constructor. Now we have this concept of constructor chaining here, because I have two constructors for this object. One that takes 3 floats, and one that doesn't take any floats. And what is this in? Well, it's written there in the note. This is what we call constructor chaining. So this is calling this constructor from this constructor. That's what the this keyword means in this context here. It means I'm calling this constructor. When this constructor is called, this is the one that's called here, and then it passes in those 3 parameters to this constructor and uses those to instantiate the object. The other thing that we see is I've got parameters x, y, and z and w here, and I also have a field called w. So what do we use this here? This is used here to disambiguate. So I've got two variables called w, and I disambiguate them by using this keyword. So that's another example of where you'd use this keyword. These are just methods here. So I've got an update method, and I have a render method on this object. So that means that every ship can do 2 things. It can update itself, and it can render itself. So what we notice in update, this is the example of using sine and cosine to calculate the object's forward vector from its angle. So the thing we have to remember here is what now controls in what direction this object moves. Which field controls in which direction the object moves? Looking up at the code there, which field of that object controls the direction of movement? Is it the forward vector? Is it the position? Or is it the angle? The angle. So the angle is the thing that you change if you want to change the direction in which this thing is moved. Because if you look what happens here, the forward vector gets calculated from the angle, and then that's what I use to change the object's position. And it's also the variable that I use to render the object, to draw the object. So it's the angle is the most important thing now, okay? Everything gets calculated from the angle. And so then I've got the key pressed code, and then I multiply by the speed. There's an example of the multiply. Just taking a vector and multiplying it by a scalar. So that has the effect of taking the vector, which is of length 1, and then making it of length whatever the speed is. And I add it to the forward vector by using the .add method on the p vector. So then we have the render method down here. And the render method, this is the push matrix, pop matrix kind of, set of API calls or processing methods that we're going to call. First of all, you call push matrix. What does push matrix do?
Saves the...
Yeah, it saves the current position and translation, saves the current translation and rotation. Alright, so that's what it's doing, it actually pushes it onto a stack. Interestingly, why it's called push matrix, would anyone like to hazard a guess as to why it's called push matrix? Yeah, that's the push. Why is it called push matrix? Why isn't it called just push? Or why isn't it called push translation rotation?
Because it stores somewhere in the matrix.
Absolutely. Okay, gold star. So that's how translation and rotation works. What actually happens is the entire sketch gets multiplied by a matrix. Did you do matrices in maths? So this is an example of where matrices are used. Matrices are used to implement translations and rotations. Did you do translation and rotation matrices?
No.
Okay.
Yeah. We've done rotation matrices.
Okay. Cool. So you know how matrices work then?
Oh, no.
You know how to multiply two matrices together?
Yes. Yeah.
Well, definitely, yeah, because we're going to make a matrix class in the second semester. Matrices are cool. But matrices are used to implement translation and rotation. So that's why it's called push matrix. Then we call it translation, rotation. Why do we do translate and rotate in that order? Somebody just throw out or hazard a guess as to why we do translate and rotate in that order. Why don't we do it rotate first and then translate?
That's just the way you have to do it.
What's that?
Rotates around the origin.
Yeah, what would happen if you flip the order of those? Would it still work? Why not? What would happen?
Would rotate about 0, 0.
Yeah, it would rotate the thing like this, around 0, 0. What you want to happen is the rotation first, so it rotates around itself and then translates. But the interesting thing is, because of the way these matrices work, you specify them in the reverse order to which you want them to happen. So if you want rotate to happen first and then translate, you put translate ahead of rotate. So it flips the order. It's because of how the matrix operations work. But this is an example here. What's going to happen first is actually translate and then rotate. Sorry, rotate happens first and then translate in this example. But you do them in the opposite, you write them in the opposite order that you want them to happen, right? So anyway, then we draw everything. Looking at this drawing code, this is all drawing around 0, 0. So we imagine that the object is located around the position 0, 0. And then we call pop matrix at the end, okay? So that's how our class works. Then we can do this. This code over here is going to instantiate two instances of the class. I've got ship and ship1. In the first example here, I'm calling the default constructor. Second example, I'm calling the parameterized constructor. And it's a good idea to get into the habit of always naming your classes with an uppercase character. So S for ship, uppercase S. So there's my two instances, and here is me now calling these two methods here, okay? So I'm calling the update method, calling the render method. And that kind of brings us to the end of last week's class. That's everything that we did at last week's class. So, how we kind of finished last week's class is we were going to make another ship class, right? And I'll give you guys maybe 10 minutes to figure out how to do this, right? So, you have one ship class up here which is controlled with the keys. Let's add another ship class. This time remembering that the direction of the ship class is controlled by which variable? Theta. Okay, so theta is controlling the direction of the ship. Let's make a ship that drives around, or that moves around the outside of the screen by itself. Now, like this. So it just follows around the outside of the screen. We've done lots of examples like this before. The reason why we're doing this is because we're going to introduce this concept of inheritance as soon as we do this. But first of all, let's just try and make the ship that moves around by itself, just to get everybody warmed up and get your brains working on a Monday morning. Just try and solve that little problem. I'll give you like 10-15 minutes to try that, okay? And then we'll come together as a class and do it together. Yeah.
Sorry,
Sure thing.
here last week, so
No problem. Yeah. Multi takes the x and it multiplies it by a number, and the y and it multiplies it by a number. So if you pass in speed, it will multiply the x by the speed and the y by that. Okay, well, let's see if we can figure this out as a class, right? So I'm going to start here with a blank tab. Actually, let's start the video. Or is it already started? It's already started. Okay, so watch carefully. If you didn't manage to figure this out, then watch carefully and try and learn from this example, you know, what you need to learn, okay? So, first of all, here's my ship class. I know my AI ship class is probably about 90% the same as the ship class, so let's just copy everything from the ship class into AI ship, right? So I'm going to go Control A, Control C, and then Control V in here to paste it in here. And then I'm just going to change this to be AI ship. I'm going to change this to be AI ship. And change this to be AI ship, okay? So now my ship and my AI ship are pretty much the same. And everything that from ship now is in AI ship. Is that okay with everybody? I haven't done anything. Just basically copied and pasted everything from one class into the other class. So I did say that the most important method that we need to modify here is the update method, right? So let's keep this bit, and let's just modify the bit that actually moves the ship, right? That's the only thing that's really changing, is the bit that moves the ship. So what I want to do now is I'm going to go, at some stage I'm going to go pause dot add, which will add the x and y components of the forward F-O-R-W-A-R-D. Alright, if I just did that, my ship is just going to always go straight up. Let's even try this, right? Let's just make sure that everything, you know, that something happens now. So there's ship 1. Let's make ship 1 into an AI ship, okay? Okay, so let me just confirm what I've done there. I've just got my AI ship code. I've taken the update method, and I've just replaced all of the if statement inside the update method by just going pause.add forward. So what will happen now is the position vector, in other words, the x and y components of the position, will have the forward vector multiplied by the speed added to it each frame. So the forward vector is always of length 1, multiplied by the speed it becomes of length 5. My starting out forward vector is 0 and minus 1, so the ship is going to go straight up. And then over here, I've just taken ship 1 and I've made it into an AI ship as opposed to a ship. Alright? Remembering, by the way, just when I was looking around, you can't do this. Alright, you can't just do that AI ship.update. Because AI ship is a type. Alright, we need to call the update method on an instance of the class as opposed to the type of the class. Alright, so you need to create the instance and call the method on it. So anyway, what's going to happen now is the ship doesn't just go straight up. Okay, so let's click the play button, and I should get one ship, and it just goes straight up and off the top of the screen there. I'll run that again so you can see it. What I need to do now is put in the code basically to change the theta angle when certain things happen to that ship. So there's my AI ship code. Now what I need to do is check to see if AI ship reaches the top of the screen. If it reaches the top of the screen, I know that its position vector on the y will be less than the 0, which is the top of the screen. So you can go if pause.x. Now pause.x is the center of it, right? So it should really be pause.x minus half w is less than 0. That means that the top of the ship has gone off the top of the screen. I need to rotate, so theta plus plus equals to half pi. Okay, so half pi is 90 degrees. Theta initially is 0, which is going to be straight up. So now theta is going to be 90 degrees, hopefully, once I get to the top of the screen. The thing I like to do is, I now know I've gone, if you notice this if statement here, first of all, there's no point checking to see if it's equal to 0. If it's equals to 0, it's probably bad, because we're dealing with floating point numbers here. Not quite sure, you know, it might not be exactly 0 depending on the speed value. It could, you know, if my speed was 3, it might go, you know, off the top of the screen without hitting 0. So another thing I like to do is go pos, that should be pos.y of course. Pos.y equals half w. So the first thing there is checking to see if I've gone off the top of the screen. If I go off the top of the screen and bring it down back onto the screen and rotate by 90 degrees, and that will make it go off to the right instead of going straight up. Let's test that and see does it work, right? There we go. So it went to the top of the screen. The y value, you know, this if statement became true. And so I moved it back down the screen a little bit, and then I rotated by 90 degrees. So let's put in the next bit of code here as well. Let's check to see if we go off the right hand side of the screen. So this will be a pos.x plus half w is greater than the width of the screen. I'm going to do the same thing as well. So I'm going to go theta plus equals to half pi. So I add 90 degrees to it. You know, I could just set this exactly as well. I can set this equals to pi. You know, if I set theta equals to pi, then it'll go straight down, because pi is 180 degrees, you know. 180 degrees would be straight down in this one as well. So then you can go pos.x equals width minus half w. So this just brings it back onto the screen a little bit. So we'll do the other two if statements then. So that's checking to see if the x coordinate of the ship goes beyond the right hand side of the screen. I rotate it and bring it down. Okay, let's do the next thing. If pos.y plus half w is greater than the height of the screen, then that means I've gone off the bottom of the screen, or the ship has gone off the bottom of the screen. So we'll do the same thing again. Theta plus equals to half underscore pi. So I add another 90 degrees to the angle, and then pos.y is going to be equals to the height of the screen to bring it back onto the screen minus half w. Now there's loads of ways. You might have come up with your own way to do this, and it's probably just as good as this. And then finally we check to see if we go off the left hand side of the screen. So if the pos.x minus half w. Oh, hang on. Let's see. If pos.x is less than half w, isn't that a better way to write it? Then that means my x coordinate, the extreme, the left-hand side of my ship has gone off the left-hand side of the screen. And then we do theta plus equals to half underscore pi, and then pos.x equals half w. Okay, so I think that should solve it, unless I've made any mistakes, which is kind of possible as I was typing away there. Why don't we run this and see if it works, and then we'll see if we can improve this a little bit by refactoring it. So there it is. Hopefully everything's working. Yeah, it's going around the outside of the screen. As it hits those if statements, I add 90 degrees, or did a weird thing. And now it didn't do it again. Did I even see it? I didn't see it.
Wait for a second. Just wait.
I'll run it again. Let's see.
That's usually down to that thing of not moving the thing back onto the screen again. It did a weird thing once, didn't it?
Yeah, drag it back across onto the screen.
So that was when I went to pos.x less than half. Oh no! Look at that. The second time around it does it just once. Can we call it a feature?
Yeah.
Yeah.
Let's call it a feature, right? Because it might take me a while to figure out why it's doing that.
It's an AI feature.
Yeah, it's a part of the AI of the ship, right? It's like a bit of an emergent behaviour there. We'll fix that another time, or maybe we'll fix it over the break. What I want to do is I want to take this program here and say, how do we improve this, right? Everybody look up for a second, okay? Because this is the most important learning outcome of the day. This is the thing that we all need to learn, and we all need to finish this class knowing this concept, right?
In the middle of the screen now.
What's that?
Why is in the middle of the screen now? Just switched. Great AI.
That's really cool. Okay, alright, we'll fix that in a minute, right? Everybody look up here for a second, right? So what have we done here in order to implement this feature? Never mind about the little if statement, but the first thing that I did was, what did I do? I copied and pasted a load of code from one class into another class. Did everyone see that? Is that a good thing?
No.
No, it's a bad thing. If you find yourself copying and pasting code from one class to another class, you have to ask yourself, there has to be a better way to do this, because we hate copying and pasting code around our programs. You know? So there is a better way to implement this type of design, and it's called inheritance. Okay, and the principle behind inheritance is that you look for similarities in your program, and you take the code which is shared amongst different classes, and you try and refactor that so that you put that code into what's called a base class. Now, let's look at this program. I'll do it, and then maybe we can talk about what it means. So I have two classes here. I've got ship and I've got AI ship, right? And I know that AI ship is about, 70 to 80% the same as ship, isn't it? Okay, so watch what I'm going to do here, everybody. I take AI ship, and I take out all of the code here that is similar. I might need to leave the constructors. But yeah, let's just leave the base class constructor. Let's just leave the default constructor, and I'll get rid of everything else, right? Okay, so there's almost everything else gone. And you notice now, of course, my program no longer compiles, because I've gotten rid of everything which is shared between this class, and I've just basically kept the update method. The only thing that differentiates AI ship from ship is the update method. You come to AI ship and you go extends ship. Alright? So extends is a new keyword in Java, and extends means when you make a class that extends another class, everything that ship has, AI ship now has as well. Okay, let's be clear about that again. That's the most important concept from today. When you use the keyword extends with a class, everything that ship has, AI ship now has as well. Yeah?
Can you extend to more than one?
No, you can only extend one class in Java. Some languages have a feature called multiple inheritance. C++ has, and so does Python. So you can extend more than one class in those languages, but in Java, you can only extend one base class. So again, be very clear, because this is the most important thing from today. In this example here, we have everything that ship has. I want to take into the AI ship class and just modify it a little bit. Change the bit that needs to be changed, right? Other than that, everything that ship has now, AI ship also has. Now you notice that there's one compiler error here still, right? You see this keyword here in the base class constructor here? See this? Now there is no, in the AI ship constructor, now there's no method, for this API call, or for this keyword to find. So what you have to do is change your code very slightly, and you use the word super. And super means call the constructor from the base class. The base class is the class that AI ship extends. Okay, so let me write up a little diagram of what we've just done here. You've done class diagrams with Richard, I guess, or somebody, have you? Have you come across class diagrams? That's a yes.
For a bank account.
Cool. Now you can see, this is where you would use a class diagram to express this type of relationship, right? And here's the class diagram. It's very simple. Take my ship class. Put everything that my ship class has. My ship has got position. It has the theta value. It has the forward vector, and so on. And it has two methods on it. It has the update method and it has the render method. And then we put this big arrow here. This big arrow means extends. And then we make AI ship like this. And now we say that AI ship extends ship. So everything that ship has, AI ship has. Everybody see that? That's the diagram that represents this relationship that we just created. And by using extends, you can create these relationships and you can save yourself duplicating code between classes and copying and pasting code. Alright, well everybody just, does anybody want to ask me any questions about that before we move on? Sure thing. So yeah, before we take a break, let's just make sure that there's a couple of very small concepts here which I just want to make sure everybody understands. Oh yeah, look. So a couple of things, interestingly, right, looking at this program again, this constructor for AI ship now no longer works. So one thing you don't get when you inherit is you don't get the constructors from the base class. You have to write your own constructors and call the constructor from the base class if you want. So AI ship doesn't have a constructor that takes 2 parameters or 3 parameters. All it has is the default constructor. So it can just construct it like that, or it can make a new constructor. Now that's one thing, when you're constructing objects, you've got to make the constructors. You don't get the constructor from the base class. The other thing is, in this example here, I say when I construct this AI ship, call the superclass constructor. If I didn't put this code in here, an interesting question would be then, what default values does it get?
Get a lot of
Nulls or empty ones? The answer actually is rather, you mightn't guess it yourself. What it will do is it will get the default values that are set in the base class constructor. I'll show you what that means. Here's AI ship, right? Here's the AI ship constructor. Let me just put in a print ln here so I can see some code getting executed here. So I'm in the AI constructor, let's say default constructor. I am going to put this code into the ship default constructor as well. And then let's say, oh, I think this has to be the first keyword. If you're using this like that, it has to be the first keyword. So there's the AI default constructor, and this isn't in the AI default constructor, this is in the ship default constructor. And then we are in the ship parameterized constructor. So I'm in the ship parameterized constructor. Constructor. And let me comment out this so I can just see the ship code, the AI ship code, without seeing the ship code. I comment out this here. Comment this here, comment this here. Let's now save everything and run, make sure everything works, and then, yeah, so now I only have the AI ship, but look at the sequence that I actually called. So first of all, we called the ship parameterized constructor was the first thing. Wow, yeah, so it's doing it in the reverse order, right? So this is interesting, yeah? So you notice that the first thing that got printed out here was the ship parameterized constructor. Why? I'm not constructing a ship anywhere. I've commented out all of that code.
Because of extending, it's still needed to.
Yeah. Yeah, you're right. Yeah, because AI ship extends ship, right? Whenever you're constructing an AI ship, you're also constructing a ship. Does everybody understand that? Because the AI ship extends ship, that means it is a ship. Therefore, you're constructing a ship when you're constructing an AI ship. How that's implemented in code is, if you don't explicitly call the constructor from the base class, the default constructor gets called for you automatically. So this is an example of something which is maybe slightly obscure, but it's the kind of thing that would come up in a Java programming exam if ever you did want to earn an interview. To know the sequence in which constructors are called. If you don't explicitly call a constructor from the base class when you do inheritance, the default constructor gets called for you. So what happens here is, I construct AI ship. Oh yeah, and you notice the very first line of code is in the AI default constructor, but even though I didn't call it, the very first thing that got executed was this line of code here. The very first line in this method is this thing which calls this constructor. So this is in fact the first thing that gets executed. Then this happens. Finally, this happens here. So that's how constructors work with inheritance. I think we should take a short break, and when we come back we'll make another subclass called a bullet subclass, and we'll be able to implement ship firing. What's that? Sure thing. While we're doing it, just the very first thing we'll do is implement proper keyboard handling so we can press multiple keys at the one time. That's a very, very simple little mod to our sketch. And yeah, that's it. Let's just take 10 minutes, okay? Okay. I just modified this program very slightly, and I actually just hard-coded the angles as opposed to added half pi. So I just said theta equals half pi, theta equals pi, pi, which is basically 3 over 2 pi, and I just hard-coded theta equals 0 again. So that just seems to fix that bug, whatever was causing it, I'm not quite sure. Anyway, like just to recap that little very important concept, right? Whenever you have classes in your program and you notice that those classes have a lot of duplicated code in them, you should consider doing this, which is to make one class extend another class instead. And that way you get everything, you know, from the base class into what's called the derived class. I might just write those terms up as well because they're kind of important terms. You'll see this concept of extending one thing. This runs across every OO language, right? Java, Python, Swift, all the OO languages have this concept, right? But they sometimes use different terms for these different, to mean the same thing. Sometimes AI ship, right, in this example here, this is called sometimes the subclass. And maybe just take a note of some of these terms in your programs or somewhere, so you remember when I use the term subclass, this is what I'm referring to. AI ship is a subclass of ship. This then is called the base class. And some books refer to it as the superclass. So this is the subclass. This can be also known as the derived class. Alright, and again, just remembering that the ship that is extending from this ship, or the class that's extending from this base class is called the subclass or the derived class. This then is referred to as the superclass or the base class. C# refers to it as the base class. Java calls it the superclass. Sometimes this is referred to as the parent class. And this is referred to as the child class. And in some books, particularly C++ books, will refer to this as being the generalization, and this is being the specialization. So they're all terms that you'll read in different OO books and in different languages to refer to the same principle, which is the principle that you take a class and you extend from that class to make a new class, which gets everything that the original class has. Yeah, let me see, is there anything else I need to say on that? No, that's okay. Base class specialization. Yeah, just a note on constructors, right? Because constructors, when you're doing inheritance, there are a couple of rules which are very logical and they make sense. But there's still a set of rules that you kind of need to know when you're doing this, right? First of all, you don't get the constructors when you extend. I'll put the super class, I'll use the Java class. Okay, if you don't explicitly call a superclass constructor with the super keyword, then by the default constructor from the superclass is called. If you don't call a constructor explicitly, yeah, I'll just put a note up here. Use super and this to explicitly call constructors. I'm pretty sure if you don't have a default constructor in the derived class, I wonder will you get an error. Let's just try it. There's AI ship. If I actually comment, if I get rid of this code here, and try and run it, will I get an error? Or will it just call the base class constructor? Yeah, it just calls the base class constructor by default. Okay. So there we go. You don't get the constructors. You don't get the constructors. If you don't call a superclass constructor, then the default superclass constructor gets called for you. So that's, because when you're constructing a derived class, you're also constructing, because it's an instance of the base class as well, it will call by default the base class constructor too. So, or we'll call it the default constructor in the base class. Yeah.
Interfaces work in process.
Yeah, absolutely. Yeah, there's two other concepts here called abstract classes and interfaces. And once we understand this, we can do abstract classes and interfaces as well, which allow you to do interfaces in particular allow you to sort of implement the Java equivalent of multiple characters. Because you can extend any number, or you can implement any number of interfaces. You can only extend one class. Okay, so we've got AI ship and we've got ship. Right. Next thing we want to do here is I want to add the ability for the ship to be able to fire bullets. Okay, so first of all, we'll do something very simple here, and then we'll try and get the bullet thing going. Okay? The simple thing I want us to do first of all is just to be able to press multiple keys at the same time. If you look at the ship update method here, it checks to see if key pressed, and then if the single variable key is the key that's pressed. Okay? So the consequence of doing our keyboard handling like this is that we can't press multiple keys at the same time, because I can only check one key. Alright, there's a little trick in processing to allow you to do this. And how this works is, first of all, in the main sketch, you create a Boolean array. I think you make it 512 as far as I remember, because there's 512 possible keys that could be pressed. So we make this Boolean array of size 512, and this Boolean array is going to hold the values of which keys are pressed from one frame to the next. So to check for a key, there's a method called keyPressed. KeyPressed is a method on your sketch as opposed to any class that you might create, and this method will get called automatically by processing whenever a key is pressed. So whenever a key is pressed, we just set the appropriate value in that Boolean array to be true. So keys at position key code. Key code is just an integer which gives you the key code of whatever is pressed, whatever key is pressed. So you just set key code to be equals to true in the key pressed, and then you go key released. And in the key released method, you just set the key of the key code to be equals to false. And that way now we have this Boolean array. Every frame, multiple times key pressed might get called in one frame and key released. But basically this Boolean array will now have a Boolean array telling us which combinations of keys were pressed. It's just a little trick. I was just Googled, how to get multiple key presses in processing, and this was the link that came up that explained how to implement this. Now if we jump over to our ship class, instead of checking all of this key pressed code here, let's get rid of this, and instead we'll just check the Boolean array to see which combinations of keys were pressed. So, okay, so instead of doing if keys at position W. I think it's lowercase w, but we might need to check this. It could be uppercase w. I can't quite remember. So we'll just check it. And then if keys at position A is pressed, we'll do that. And then if keys D. So this hopefully going to allow us. I'm just going to double check to make sure, because I can't remember if it's uppercase or lowercase characters you need to do here. Oh yeah, so then of course we also need to instantiate the ship again. And put it back into the scene. And then not forget to call ship update and ship render. And then hopefully we should be able to press multiple keys at the same time. So it's W, up. Okay, so I think it's uppercase. Let's just check that works. Nope. Okay, I'm just going to get this from one of my other sketches. Excuse me for a second. I'm just going to double check this code before I give it to you, and then we'll go and make the bullet class. Documents. Keys, key code equals true. Keys, key code equals false. Key code, key pressed, key released. Then my ship class. Check key. Sorry about this. Should have checked this before I showed it to you. No, it's the lowercase keys. Okay, so why is it not working? Oh, that's really weird. Why is it not working? Keys, key code equals true. Key code, key pressed, key released. Okay. Okay, I'll come back to that. I'm not quite sure why it's not working. I'll check it because there is the next part of this exercise I'd like us to work on, which is to be able to create bullets. So, it only works in processing. It works in processing 2, but not processing 3. Is that the case? In processing 3, it's weird. Why is it not working for me? Anyone? The same code. Keys W, keys A and D. You use capital W.
Yeah.
It didn't work for small. Okay, now it's working. Weird. Okay, I thought it was capitals alright when I remember it. Yeah, so look, you can press multiple keys at once. Alright, that's cool. Okay, I'll put that code up because I think it's working now, right? You can take it down and use it in your sketch. Right, the next problem that we want to try and solve, or the next bit of this that we want to try and make, is the ability to keep track of bullets in this game. And I want to be able to press the space key and for my ship to be able to fire bullets, for them to get added to the scene and removed. So let's try and come up with a little specification before we try and implement it. Number one, what I want to happen here is, actually I'll just describe the scenario for you. Here's my ship, right? Everyone look up for a second. Here's my ship. When I press the space key, I want to be able to create these new bullet objects, alright? Let's not worry about the timing or anything like that, but basically whenever I press the space key, I want to create these new bullet objects, right? I want these bullet objects to be able to, same as the ship, they have to encapsulate their behavior and they have to encapsulate their state. So in other words, the bullets have to just look after themselves once they're created. So they have to move by themselves. Once they get to the edge of the screen, they have to get removed from the game. So I'm no longer going to keep track of them once they get to the edge of the screen. We won't worry about that for now. First thing we need to do is we need to make a bullet class. Make a bullet class, right? Second thing we want to do is I need to make an array list. Let's see. Let's say not. Yeah. Okay. This is okay. Let's make an array list of bullets. When I press the space key, what do I want to do? I want to instantiate a new bullet. S-T-A-N-T-I-A-T-E, bullet. And I need to give that bullet some value. So I need to give it its initial position and its initial theta value so that it's rotated and positioned at the correct place in the scene. Where am I going to position it? Well, I'm going to position it relative to the spaceship. A good way to get started here is just to give it the same starting position as the spaceship. Alright? That way it'll start in the center of the spaceship. In the bullet update method, so let's add a bullet update method. And let's add a draw method, okay? The bullet update method, what is it going to do? It's going to just take the bullet position and move it so that the bullet looks like, it's moving each frame. Alright? In terms of doing this, in terms of an OO way of doing this, can we use inheritance to do something here? What do you guys think? Is there any similarity between the ship and the bullet and the AI ship? Yeah. They share position, they also share the forward vector, and they share the theta thing. So is there a way we can do this in a kind of an OO way to sort of duplicate, to save us duplicating some code? Could we make the bullet extend the ship? We could, but it might not be the ideal solution because when you do extends, right? Yeah, it gives you everything. Not only that, extends semantically means is. Right? So that means a bullet is a ship. Maybe that's not a good way to do things. Maybe a better way to do it would be to take some of the code which is from the ship class and put that into a base class and then make the bullet extend that instead. So, a good way to solve this problem is to basically make our kind of inheritance hierarchy a little bit more complicated. And say that we have some base class called GameObject. And this is going to have stuff like the position, the forward, and it will have the theta value. And then make ship extend this. And then AI ship extend this, and then make bullet extend GameObject. That might be a better way, because that way we avoid the duplication, and also we have the benefits of inheritance, right? So let's say we've got a base class called GameObject, ship extends GameObject, AI ship extends ship, bullet extends GameObject, like that. And then you can just put anything that's shared between all of the classes into the GameObject base class. Does that look like it might work? Alrighty, why don't you try that? Whenever I press the space key, we want to instantiate those bullets, add them to some array list, so I'm keeping track of multiples of the bullet object, right? I think that's a good solution. We'll work on that for the last half an hour of the class, right? I'll give you guys maybe 15-20 minutes, and I'll kind of work on it as well, and we'll come together at the end and see what solution we came up with, okay? Okay. Yeah, so Okay, so we're kind of rushing this last bit a little bit. Maybe it'd be nicer if we had some more time to contemplate this, but we'll finish this just so you can understand the concept, right? First of all, I've refactored everything. This is my new class diagram to represent the classes I'm creating in this. So we decided we're going to have a game object which everything is going to extend. And we can add more things to this scene as well. We'll probably add the star and maybe some other things. We can add lots of things that extend game object. And we're basically deciding that everything in this scene is going to extend game object. So everything is going to have a position, forward vector, rotation, and so on. Then bullet and ship are going to extend game object. AI ship is going to extend ship. This is be our new hierarchy, right? And this is the steps I think we need to do in order to put bullets into the scene. Done our game object. Make the ship extend game object. Make the bullet extend game object. We're making an array list of bullets because our scene's going to have multiple bullets, right? So we need to keep track of them somewhere. Let's use an array list because that can grow and shrink. Then we're going to make instance of the bullet. Whenever the player presses the space key, we'll create a new instance of that class, add it to the array list, set the bullet fields, so set things like the position and the rotation, and then add it to the array list, and then make the bullet update itself. So we'll do all of this kind of very quickly, and I'll give you a variation of this to work on in the lab. We just have 6 minutes left, so let's do this pretty quickly, right? There's the AI ship. There's my game object now. So anything I think everything needs to do, I put into the game object class. There's the ship class. The bullet class. Bullet's going to do two things. First of all, let's put in a void draw method. Or we called it render, didn't we? So the bullet rendering is going to be similar to the other rendering. Let's go push matrix. Let's draw the bullets as if they were centered around 0, 0, 0, and pop matrix. Then let's do translate. Let's translate to pause.x and pause.y. Now the cool thing is I haven't put pause.x and pause.y into this, so it's getting